Welcome back to my recorded classes. So this recorded class we are discussing section number 5.3 Bayes Theorem. Topic from module number 5 discrete probability. So let's start the topic. So last recorded class we are discussed how to find the conditional probability, correct? So what was the conditional probability? Remember, probability of A given B equals probability of A intersection B divided by probability of B. Hope you remember that one. Here probability of the event A under the condition B already happened, correct? This event already happened. So what is the probability of A, correct? So probability of A intersection B divided by probability of B. Also we studied the multiplication theorem. So this is the conditional probability, correct? Conditional probability. We did in the 5.2 section. Also we studied what is the multiplication rule in the probability. Multiplication rule in the probability, that means probability of A intersection B equal to probability of B multiply probability of A given B, correct? Probability of A given B. So this was we are studied, we are discussed the questions last recorded class. Now we will go to the main idea now. Bayes theorem. Okay, Bayes theorem. Bayes theorem also we are using for calculating the conditional probability. This idea, but the reverse probability. You can see that one. Before that, see Bayes theorem where we are applying the Bayes theorem. Bayesian theorem in machine learning, especially machine learning applications. You can see credit card fraud detection, that field using spam filtering, medical diagnosis, pattern cluster data set, or marketing campaign performance, help robot to make decisions, okay, to calculate the next step of the robot when the already executed step is given, correct? It is like a conditional probability. And reconstructing the clean images from noisy image, weather prediction we are using, speech emotion recognition we are using, and estimating gas emissions and forensic analysis. A lot of applications we are using the Bayes theorem, okay, in different field. Especially these are the applications in the machine learning field. Or we can see, we can conclude like this: applications of Bayesian network, document classification, gene regulatory network, medicine field, and spam filtering, system biology, and image processing. Many field they are having some applications of Bayes theorem. Okay, so it is the main topic actually for machine learning and all other fields also. Okay, medical field also. This main rule, main theorem this is. So Bayes theorem. So before coming to the Bayes theorem, let's see some introduction to the Bayes theorem. So Bayes theorem was discovered among the papers of English minister and mathematician Thomas Bayes. Okay, he is published a paper regarding in the Royal Society 1763. So he is his name only. This theorem is familiarized. Bayes theorem, Thomas Bayes. Now Bayes theorem calculate the conditional probability. As I told, Bayes theorem also calculating the conditional probability, whatever we have discussed in 5.2, but here reverse probability I will tell you later, that one, of the event based on the values of specific related non probabilities, correct? So it is just a calculation of conditional probability. Now Bayes theorem states that conditional probability of an event based on occurrence of another event is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. Okay, let's go to the problematic view or live questions, so that you will understood more. Okay, instead of studying theoretically, we can go to the some application questions so that it is easily understood. So Bayes theorem just calculating the conditional probability. Now how it is working, you can see phenomenon of existing Bayes theorem or reverse probability. Okay, we are calculating the reverse conditional probability. Now see, let's start with one example. There are two bags. Okay, we have two bags, bag number 1 and bag number 2. See, so that means the sample space, you can see on the side in the picture, sample space divided into two partitions. Okay, this is the sample space. This is divided into two partition. One is bag number 1, second one is bag number 2. Disjoint partition, like different partition. One is bag number 1 and second number is bag number 2 partition. Okay, this is the partition of the sample space, main partition. Okay, now that main partition continuing with another events. You can see there are two bags. Bag number 1 contains 2 white and 3 red balls. Okay, so bag number 1, 2 white ball is there and 3 red ball is there. Okay, 3 red ball is there. And bag number 2 contains 4 white balls and 5 red balls. 4 white balls and 5 red balls are there. Now what we are doing, one ball is drawn random from one of the bag. Okay, one ball is drawn random from one of the bag, either bag number 1 or bag number 2. Okay, one of the bag we are taking one ball. Here we can find the probability. So whatever 5.2 we are studied is, previous section we are studied, we can find the probability of a ball drawn, probability that the ball drawn is of a particular color, for example red color, if we are given the bag from which ball is drawn. That means we can find the probability of a particular color ball. For example, probability of red color ball. Okay, I am just rounded here. You can see probability of a red color ball given that it is from the bag number 1, like that. Okay, that is what we did the last section. What is the question? Probability of choosing a red ball given from the bag number 1. Okay, bag number 1. We can calculate this one. We studied the conditional probability, how to calculate this one. Probability of a red ball. Okay, R means this is the red ball from B1 means bag number 1. Okay, what is the probability of that one? We can calculate that one. Or probability of another ball, for example the white ball. Okay, for example probability of a white ball given from bag number 1, drawn from bag number 1. We can calculate by using normal conditional probability. Correct? This is we studied in 5.2 section how to calculate the conditional probability. Now you can see this situation. You can see the tree diagram of this situation. For example, starting from here, we have two partition in the sample space. One is bag number 1 and the second number is bag number 2. Bag number 1 we have 2 white ball and 3 red balls. Bag number 2 we have 4 white balls and 5 red balls are there. Correct? Now see, that means bag number 1, this event, see bag number 1, this partition continuing by event, we have white ball option, we have red ball option. Correct? And here also bag number 2 also we have white ball option and red ball options are there. Correct? Now how we are this tree diagram connecting to the probability. For example, E1 means the event choosing the bag number 1. Okay, and E2 be the event choosing the bag number 2. I am just representing E1 first event. Okay, I can mark, I can see here E1 means choosing the bag number 1 and E2 be the event means choosing the bag number 2. Correct? So you can see now. So this is the E1 and E2 events, and you can see another one, that is the partition E1 and E2. Now from this partition you can see what are the events coming. White ball is there and red ball is there. Now in our question here we are drawing a ball from one of the bag. That drawn ball is a red color, for example, a particular color only in this question mentioned. I am taking red color. See here the red color I am rounded. The chosen ball is red color from a particular bag. For example, bag number 1 if you are choosing a red color, or bag number 2 a red color. So getting a red color we are taking as a event A. A means, what is the meaning? The drawn ball is a red ball. Correct? It is a red ball. So this case what we can do? We can calculate what is the probability of a red ball. Red ball means capital A we are representing from the bag number 1. Bag number 1 means E1. Event E1. Correct? We can calculate this one. And probability of a red ball from the second bag also we can calculate. This is what we are studied in 5.2 section, conditional probability. So how we are calculating the easier way, like this. For example, here we write what is probability of E1. Probability of E1. Here we are writing what is probability of E2. Probability of E1 means, what is the meaning? Probability of E1 means probability of selecting the bag number 1. Okay, bag number 1 selecting, what is the probability? How many bags we have? We have 2 bags, correct? Bag number 1 and bag number 2. So what is the probability of selecting bag number 1? 1 divided by 2, because bag number 1 we have only 1 bag, correct? Divided by how many bags totally? 2, because we know the probability how to calculate, number of favorable cases divided by total number of cases. So number of bag 1 means 1 divided by total number of bags is 2. So probability of E1 equal to half. That means 50-50 chance. We have 2 bags are there. One of the bag taken means 50-50 chance. Bag number 1 or bag number 2. Like tossing a coin. 50-50 chance. Getting a head means 50%. Getting a tail means 50% chance. That means 1 by 2, 1 by 2. Correct? So probability of E2 also, probability of selecting bag number 2. That also half. Correct? 1 divided by 2, because we have 2 bags, out of that 1 selecting. So 1 divided by 2. So always we are writing probability of E1, probability of E2 here in this tree diagram. Here we are representing. Now see in this one, the second events, okay, continuing event, bag number 1 we have the white ball and we have the red ball, correct? Now what is the probability of getting a white ball in bag number 1? We are representing that one, probability of white ball, correct? From bag number 1 means E1, correct? Probability of bag number probability of selecting a white ball from bag number 1, we can represent like this one, white given E1. E1 means the event bag number 1, correct? So what is that probability? In bag number 1 we have 2 white balls. How many total balls are there? 2 plus 3, that is 5 balls. So what is the probability of a white ball from bag number 1? That is number of white balls, that is 2, divided by total number of ball, that is 5. 2 divided by 5. Hope you understood that one, correct? 2 divided by 5. Same way, if you want to find probability of selecting a red ball from the bag number 1. Bag number 1 means I am representing the event 1. How can we write one? Probability of R over R given E1. Probability of R given E1, probability of red ball from first bag, correct? So how many red balls we have? 3 red balls, divided by how many total balls? 5 balls are there, correct? So this is the conditional probability. Probability of a white ball from bag number 1, 2 by 5. Probability of a red ball from bag number 1, 3 divided by 5. If you are adding these two, you will get 1. 2 divided by plus 5 plus 3 divided by 5 means you will get 1, the probability, correct? And here also, see, here also this half plus this half, you will get 1, total probability. Here also 2 divided by 5 plus 3 divided by 5 also you will get 1, total probability. Now same way, if you want to calculate probability of selecting a white ball from bag number 2, correct? Or E2, bag number 2, or we can represent E2, correct? How we are calculating that one? Probability of selecting a white ball from bag number 2. How many white ball in the bag number 2? That is 4. Divided by how many total balls in the bag number 2? That is 9 balls. So 4 divided by 9, correct? Now same way, if you want to calculate probability of a red ball from bag number 2. Bag number 2 means E2. How we are writing that one? Probability of red from bag number 2. How many red balls are there? 5. Divided by how many total balls? 9. 5 divided by 9. So conditional probability like this easily we can find by using this tree diagram, or normally whatever we studied in 5.2 section, we can calculate that one easily. That means probability of a red ball from first bag we can calculate. Probability of a red ball from second bag we can calculate, correct? Now here in the Bayes theorem, what is the question is that it is just like a reverse probability. Reverse probability means, see, this is the Bayes theorem question, okay? Bayes theorem, Bayes rule or Bayes theorem, what is the question here? Can we find the probability that the ball drawn from a particular bag, if the color of the ball drawn is given? What is the question? Just to reverse that one. That means the probability ball drawn from a particular bag, okay? That means the probability of a particular bag means bag number 1 or bag number 2. That means probability of that a ball drawn from bag number 1 under the condition given that if the color of the ball is given, for example red ball, okay? What is the probability of a ball selecting from bag number 1 under the condition given that it was a red ball, correct? It was a red ball. This is what the question in the Bayes theorem. See what is the difference actually here and here, you can see. See here, probability of a white ball from bag number 1, 2 by 5. Probability of a red ball from bag number 1, correct? See what is the difference between this and this, you can see. This is just a reverse probability. Here see, we calculated what is the probability of a red ball from bag number 1. Bag number 1 means either you can write E1 also. We got the answer 3 divided by 5, correct? Here you can see that one in the tree diagram. See here what happened, red color. See, particular event is on the top side. The partition event coming on the downside, B1, correct? B1 is on the downside. So I can write here, see the B1. This is the partition, correct? The partition event on the downside and the particular event on the top side, correct? Particular event is on the top side. But in Bayes theorem, what happened? Partition is coming on the top side, correct? Partition, that event, main event coming on the top side, and the particular event that is coming on the downside in the probability, correct? So same, both are the conditional probability, but Bayes theorem, it is just a reverse conditional probability, reverse probabilities. Probability it is that probability of a B1, that means ball bag number 1, given that it is a red ball, correct? So this is the partition divided by the sub event, correct? Main partition divided by sub event, but here the event divided by the given the partition. Okay, under the condition partition is given. So this is the difference between the Bayes theorem and the normal conditional probability. So it is both are conditional probability, but here the phenomenon of Bayes theorem, existing Bayes theorem, is reverse probability. Okay, I hope you understood the idea from here. So whenever you are doing the question, you can connect with the tree diagram like this. Okay, just first we are doing the partition of the sample space, main events E1 and E2, and this event, main event, continuing with some sub event A, B, like that. Second also continuing with some sub event A and B also. For example, here last question we taken red ball, white ball, correct? Red ball and white ball, like that. And main partition E1 and E2 we are taken bag number 1 and bag number 2, like that, correct? So probability of E1 we are writing here, this line, probability of E1. Probability of A given E1 we are writing here. That means we are calculating the probability of a red ball under the condition E1 from the bag E1. That is why E1 is on the down, correct? Normal conditional probability, that is probability of A given E1. And same here what we are writing, probability of B, that means the white ball from the bag number 1, E1, correct? And same here, probability of A given E2, probability of a red ball from the bag number 2, and here probability of a white ball, that means B, divided by under the condition which bag it is, second bag E2, correct? So this is the idea, tree diagram. This is the tree diagram that you can easily understood the Bayes theorem. Okay, for Bayes theorem. So here probability of A given E1, that means probability of a red ball from the bag number 1. This is the normal conditional probability, because here see the partition is coming on the downside, correct? Partition is coming on the downside. This is we are studied in 5.2 how we are calculating this one. But in Bayes theorem 5.3 section, how the reverse probability will come, Bayes theorem, okay, the Bayes rule, how the condition reverse probability will come. Here the question like that, probability of a partition, selecting a partition, ball from a partition under the condition it is a red ball, it is a white ball, like that, a particular event, correct? This is we are calling the Bayes theorem, or we are calling the reverse probability. Okay, reverse probability. Okay, so here partition should be partition, main partition, you can see on the top, that probability we need to calculate under the condition the particular event chances are giving. Okay, so this is what the question Bayes theorem we need to do here. Okay, now we will come to one more example, phenomenon of existing Bayes theorem, example number 2. Suppose that there are 3 bolt producing machines. How many machines are there? There are 3 bolt producing machines For example, sample space we are dividing into 3 partition. 3 machines are there producing the bolt. Okay. First machine we are calling M1, second machine we are calling M2, third machine we are calling M3. That means our sample space we have 3 partition. Okay. So 3 machines in different capacity. First machine producing 30% of the bolt. 20% of the bolt is coming from the second machine and 50% coming from the third machine. Okay. And the machine also produce defective bolt. Okay. These 3 machines producing bolt, sometime defective bolt will be there. More good bolt will be there, but some are the defective bolts also will be there. Correct. So the machine will produce defective bolt 5%, 3% and 2%. That means first machine producing bolt 5% defective bolt, not good. Correct. And 3% not good in second machine. And 2% of producing bolt are not good in machine 3 respectively of their production. Now what happened? We are taking one bolt. So 3 machines they are producing the bolts. So what happened? The quality controlling for what we are doing, we are taking one bolt random. Correct. We are taken out a bolt randomly and found to be defective. That bolt found to be defective, not good bolt. Correct. Determine the likelihood, determine the possibility. Okay, that it will be from machine 3 will manufacture that bolt. Machine 3 manufacturing that bolt. So this case we can use the Bayes theorem only, because machine 3 means it is the partition. Correct. Machine 1, machine 2, machine 3, these are the main event partition in the sample space. Correct. So machine 3 producing that bolt, what is the probability? So this situation you can see the tree diagram also, you can do like this. Okay, we have 3 machines, machine number 1, machine number 2 and machine number 3. Machine number 1 producing 30% of the bolt. Correct. Machine 2 producing 20%, machine 3 producing 50%. Now what is our sub event here? When we are taking one bolt, okay, randomly, we found it is defective. What is the probability? Correct. We found it is defective. So for example, machine number 1, some bolt we are getting defective, some bolt we are getting good bolt. Correct. Second machine also defective bolt will be there, good bolt will be there. Third machine also defective will be there, good bolt will be there. Correct. Now the percentage of defective bolt is given from machine number 1. How much percentage defective bolt producing? For example, 5%. Machine 2, how much percentage defective bolt? 3%. Machine 3, 2% defective bolts are there. Correct. Now I told you just before, this is this 30%. What is the meaning? Probability of the event E1. E1 means the first machine. Okay, and E2 means the event producing second machine, bolt producing from the second machine, and E3 means the bolt producing from the third machine. Okay, so what is the probability of E1? 30%. 30% means we need to convert into number. Correct. Percentage, how to convert into number? 30 divided by 100. That means the probability you will get to 0.30. Correct. So that is the probability of E1. Now probability of E2. What is probability of E2? We are writing here 20% means 0.2, and probability of E3 50%, that means 0.5. Correct. So the first line we are representing probability of E1, probability of E2, probability of E3. Now see here our event is defective bolt. Correct. So A means, so what I told, E1 means bolt producing from machine number 1. Correct. E2 means what I told, bolt producing in machine number 2. E3 means what is the meaning? Bolt producing in machine number 3. Correct. Now what type of bolt we are checking here? Defective bolt. Correct. One bolt we are taking random, that will be defective. So what we are defining the event A, sub event means defective bolt. Correct. Defective bolt. Correct. Defective bolts. So this D letter I am used here for defective bolt. That event we are representing by capital A. Defective bolt means capital A we are representing for defective bolt. Now for example, this 5% is what actually? Probability of a defective bolt. That means A from which machine? Machine number 1, that is E1. Okay, probability of A given E1 is 5%. 5% means what is that number? 5 divided by 100, that means 0.05. Correct. Now The second machine defective is 3%. That means probability of defective bolt. That means A from machine 2. That means E2. Correct? What is that number? 3%. That means 0.03. 3% means 3 divided by 100. Now same here, 2% from machine 3 defective bolt. That means probability of A means defective bolt from machine number 3, that is E3. Correct? That is what the number 0.02, because 2% that we are writing here. Correct? Now if you know this number, if you know this 0.05 here, this line is 0.05, you can write what is this one, good bolt. Correct? Because total probability should be 1. Total probability, it should be 1. So if you want to write the good bolt probability, you can just subtract from 1. So 1 minus 0.05, that number you can write here. That means 0.95 we will get here. What is that number actually? Probability of a good bolt. Correct? If I am representing by G from machine number 1, that is E1, is 0.95, because total probability these two will be 1 here. Same like here we can write the number probability of a good bolt from machine number 2 we can calculate, and similar here probability of a good bolt from machine number 3, that is E3, we can calculate here. Just 1 minus the next event we can calculate. Correct? So like this calculation we can do normal probability. But here the question is that what is the probability that, okay, or what is the likelihood? Likelihood means based on the hypothesis. Correct? Assumptions. So probability of, okay, probably determine the likelihood that machine 3 will manufacture that bolt. One bolt we are taken, that bolt is defective. Correct? That bolt coming from machine 3, what is the probability? Correct? So probability of that will come from machine 3. Machine 3 means the event 3, under the condition that is a defective bolt. Defective bolt means what we are representing? Capital A. What is this one? Correct? This is what our question. This is we can do by using Bayes theorem only. Correct? Because E3 coming on top, partition is coming on the top, it is reverse probability. Correct? Partition is coming on the top, down it is coming the sub event. Correct? The main event on the top side, that means the partition. Correct? Partition on the top side means we are using Bayes theorem. Okay, I hope you understood what is the meaning reverse probability and normal conditional probability. Okay, now we will go to the Bayes theorem. So Bayes theorem, okay, existing condition, okay, or phenomenon of existing Bayes theorem. Okay, what is the situation we are using Bayes theorem? We discussed these two example number 1 and example number 2. Okay, now we will go to the Bayes theorem now. Okay, before going to the Bayes theorem, we need to know what is the meaning partition, okay, and what is the meaning total probability. After that, Bayes theorem. For example, partition. What is the meaning partition? You can see one picture here. We have a sample space here. This is the sample space. Now, this sample space we are divided by many partition. See, E1, E2 partition, E3 partition, E4 partition, correct? E5, E6, E7, E8. Last we are written En. Okay, I'm just putting dot. Many partition. Okay, sometimes 2 partition you can take, or 3 partition, or 4 partition, like that. Correct? Now, E1, E2, E3, E4, like En. This event, a set of events we are taken, E1, E2, E3, En, are said to represent a partition of a sample space. Okay, this event we are telling a partition of a sample space means EI intersection EJ should be empty. That means if you are taking any 2 partition, for example E1 means this is the partition, and E2, this is the partition. Correct? What is the intersection of these 2 partition? Nothing. Correct? These 2 are not intersecting. There is no common portion. So intersection is empty. Like that, if you are taking any 2 partition, intersection should be empty. For example, E1 and E3. What is the intersection of these 2? Empty. If you are taking E3 and E4, what is the intersection? Empty, because there is no common portion. So if you are taking any pair of event, E1, E2, or E2, E3, or E3, E4, or E1, E3, always the intersection will be empty. That is the meaning EI intersection EJ equal to 5 should be an empty set. This is the first condition need to satisfy. And the second condition is that E1 union E2 union E3 union up to En should be the sample space. For example, here see, if you are taking the union means the complete, full, correct? So E1 union E2 union E3 union E4 union E5 union E6 up to last, what we are getting totally, that union should be the sample space, correct? Full portion. So that is the meaning, the second condition, E1 union E2 union E3 union up to En equal to the sample space. Now third one, probability of any event should be greater than or equal to 0. That means probability, for example, probability of E1 should be greater than or equal to 0. 0 or more than 0. You know, probability always it should be positive, and maximum number is 1. Maximum value is 1, correct? Probability value always from 0 to 1. We studied in 5.1 section. All of you remember that one. So probability of any event should be greater than or equal to 0. Probability of E1 greater than or equal to 0. Probability of E2 should be greater than or equal to 0. Probability of E3 should be greater than or equal to 0. Like that. Okay. So a set of events E1, E2, E3 up to En is said to be a partition, represent a partition of a sample space, means it should satisfy the first condition, second condition and third condition. Just remember this idea. Okay. Now we are going to calculate what is the meaning total probability. Okay, total probability. What is, how to calculate the total probability? For example, E1, E2, E3, E4 up to En be the partition of a sample space. Just now I told what is the meaning partition, correct? Now see, you can see this figure also, E1, E2, E3, E4, E6, E7, last one En. These are the partition of a sample space. You can see the partition because each event intersection is empty, union is a sample space, and probability should be greater than or equal to 0. This should be satisfied, correct? And A be any event associated with S. Okay, and we are taken another event, that is we are calling A. See, you can see the A here represented by a circle. You can see in that figure, this is the A event, correct? This A is coming here in E1, E2, E3, E4, all the portion A is coming, correct? Now, so E1, E2, etc., En be a partition of a sample space, A be any other event associated with the sample space. Now probability of A means, how we are calculating probability of A? This, before coming to this rule, you can see this tree diagram. This tree diagram you can see. For example, here I am taken 3 events. Okay, 3 partitions, E1, E2 and E3. These 3 we are calling partition, correct? So first partition E1, second partition E2 and third partition E3. These 3 are partition of a sample space, okay, or main event. So this event connected with another event A, B we can take, or A we can take, particularly we are taking one event here, A or B, A, B, like that. Okay, it is connected with the sub event, outcomes or sub events. Now see, as I told you, this line representing, this is probability of E1. This is probability of A given E1, probability of A given that E1 is given. This is happening already given, correct? This is already given. What is the probability of A given that E1 is given, correct? Probability of A given E1, conditional probability. What about this one? Probability of this line, what is representing? Probability of B given E1, correct? And this one represent probability of A given E2, correct? Second partition. What about this one? This line, probability of B given E2, normal conditional probabilities, correct? Now this one, probability of A given E3. What about this one? Probability of B given E3, correct? Now see, if you are taking one event represented by A, see this figure you can see, we are taken one event, we are calling it as A. Here I am marked that event. See, I am just rounded A. Okay, it is coming in all partitions like this. Okay, so if you want to find the probability of this one, okay, probability we need to calculate what is the probability of a total probability, correct? Total probability means what we do, just take probability of E1, this branch, see I am highlighting this branch, probability of E1 multiply probability of A given E1. Okay, what is the next branch? Wherever A ending with A, wherever the branches ending with A, because we are calculating probability A, correct? Now plus probability of E2 multiply probability of A given E2, this branch, plus probability of E3 multiply probability of A given E3. This is what we are calling total probability. So wherever that event coming, take the probabilities and add, use the multiplication rule that we are discussed in 5.2. So probability of E1 multiply probability of A given E1, probability of E2 multiply probability of A given E2, probability of E3 multiply probability of A given E3, correct? Because we are calculating total probability of A, correct? A event. If you are taking B, just other one, probability of E1 multiply probability of B given E1, plus probability of E2 multiply probability of B given E2, probability of E3 multiply probability of B given E3. But here total probability of the event A, correct? So probability of A means here we are taken only 3 partition. So how can we write that rule? You can see that rule how we are writing. Probability of A equals probability of E1 multiply probability of A given E1 plus probability of E2 multiply A given E2, probability of E3 multiply probability of A given E3, plus like that up to the last. This is what we are calling total probability. I hope you understood why we are using total probability, because each branch we need to consider. See, first partition there is one A, second partition there is one A, third partition there is one A. So total probability means adding, multiply this probability, use the multiplication rule, after that add each one. First partition under A probability, then second partition A probability, then third partition, like that add, so that we will get the total probability. So this is the idea, total probability. That is why we are calling total probability, correct? So how can we write the rule? Total probability of the event A equal to, first we are starting with this line, probability of E1 multiply probability of A given E1, correct? Probability of E1 multiply probability of A given E1. This is what the multiplication rule in 5.2 we studied, plus the second one, second partition, probability of E2 multiply probability of A given E2, plus probability of E3 multiply probability of A given E3. If we have 3 partition, we are writing like this. If we have 2 partition, we write up to this one, correct? If we have 3 partition, one more time extra will come like this. Probability of E3 multiply probability of A given E3. This is total probability, okay? So here this rule we are written generally, n partitions are there. So we are written up to probability of En multiply probability of A given En. I hope you understood what is the meaning total probability. Now from this total probability we are going to the Bayes theorem now. Bayes rule we are discussing now, okay? So Bayes theorem, see, before going, once more I am considering this tree diagram so that you will understood easily. This is the first partition E1, this is the second partition or main event E2 and E3, correct? 3 partitions. Now this partition we are taking a particular event A, here also A will be there and here also A will be there, correct? Now remaining value we can take it as B, next event, for example A complement or B, like this, okay? Now just now we discussed how to calculate the total probability, correct? Total probability how to calculate we studied. Now this line what is representing probability of E1 we can write here, probability of A given E1 we can write here, and this line we are telling probability of E2, this one probability of E3, and here probability of A given E2, and here probability of A given E3, correct? Now same way we can write here probability of B given E1, here probability of B given E2, correct? And here probability of B given E3 like this. Okay. Now I am coming to the Bayes theorem now. Okay. Bayes theorem we are concentrating in a particular partition, correct? For example, if E1, E2, En are the n non-empty events which constitute a partition of a sample space. These are the partition E1, E2 up to En. This example I am taken 3 partition, correct? One is E1, second E2 and third one is E3, correct? Now E1, E2, E3 up to En are pairwise disjoint. Disjoint means we defined already, we discussed already. E1 intersection E2 should be empty. Each two pair if you are taking intersection will be empty. That is the meaning pairwise disjoint. And E1 union E2 union up to En, what will be get? Sample space. Now A be any event with non-zero probability, A be any event we are taking, then probability of Ei given A. Okay, that means for example here, okay, for example here I am defining the Bayes rule or Bayes theorem. So here for example we need to calculate probability of a particular partition or particular event, main event, probability of E1 given that A is given like this. Okay, partition is on the top side, that you can remember like that, Bayes theorem. This is the partition, correct? Partition under the event A, correct? So if you want to calculate this probability, what we do, just take the probability in the particular partition. Okay, probability of Ei multiply probability of A given Ei. That means if here he is I, same I here, I and I, same partition. So probability of a particular partition, okay, under the condition A is given, that event A already happened like that. So here what we write, for example, probability of E1 given A. Okay, so E1 means only we are taking the first partition. Okay, so this side what is the probability? See this one multiply this one. This is the probability of E1 given A. That means what we can write, probability of E1 multiply probability of A given E1 divided by total probability. Total probability means, okay, I am just writing total probability. Just now we discussed what is the meaning total probability, correct? Total probability means wherever A coming, all we need to take. Here one A, here also one. So this branch we need to take, multiply this, and this branch multiply this. This is the downside. So probability of a particular partition divided by total probability, correct? This is what the Bayes theorem telling. So probability of Ei multiply probability of A given Ei divided by the total probability. This is the total probability. You can see in particular here for one example. Probability of Ei given A equals probability of E1 multiply probability of A given E1 divided by total probability. Probability of E1 A given E1, E2 A given E2, E3 A given E3 up to the last. Top side only that particular partition, probability of E1 given A, correct? So this is what the Bayes theorem statement or Bayes rule telling. So I will write here the rule here, probability of Ei given A equal to, Ei means the partition, whichever partition we are taking, okay, in that sample space, equal to, what is the rule actually, equal probability of Ei, probability of that particular partition multiply probability of A given Ei, probability of that event A given that Ei happened, correct, divided by total probability. Total probability means we started from first partition, probability of E1 multiply probability of A given E1 plus probability of second partition, that is E2 multiply probability of A given E2, like that it is continuing, full partition we are taking, that is the total probability, correct? So this is the idea here in this question, Bayes theorem. This is what we are telling, Bayesian rule or Bayes theorem or Bayes rule, correct? Now one example I can show here. For example, if I want to calculate probability of E2 second partition given A, equal to, how we are writing this one, this rule, probability of E2 given A. Okay, we have only two partition, for example. Okay, we are taking only two partition in the sample space. One is E1 and the second one is E2. So how to write this rule, probability of E2 given A? So how can we write? See, EI, this EI should be here and here. Down, total probability, it is same always. So probability of E2 given A means probability of E2 multiply probability of A given E2, correct? Divided by total probability means starting from first partition, probability of E1 multiply probability of A given E1 plus second partition, probability of E2 multiply probability of A given E2, because here we have only two partition, so we are stopping here. This is what the Bayes theorem in two partition such that probability of E2 given A, correct? So this is the idea of the Bayes theorem. I hope you understood the idea. So let's do one example here so that you will clear. For example, there are two bags. How many bags are there? Two bags. That means we have two partition. See, I can see the picture also. This is the sample space. We have two partition. One is this partition, bag number 1, and second one is partition 2, bag number 2, correct? Two partitions. So here you can start first partition, bag number 1 and bag number 2, first event and second event. Now bag number 1 contains 3 red balls and 4 black balls, correct? So 3 red and 4 black. Totally how many balls? 7 balls are there, correct? And bag 2 contains 5 red balls and 6 black balls are there. So 5 plus 6, 11 balls are there in bag number 2. Now one ball is drawn random. One ball we are taking from here random from one of the bag, okay, and it found to be red color. What color ball we got? Red color. One ball we are taken random, correct? One ball we are choosing random, one of the bag, okay, either bag number 1 or bag number 2. That ball found to be red color. Now find the probability that it is drawn from bag number 2. See, the partition is given here, bag number 2, drawn from bag number 2. That means what we need to calculate here? Probability of bag number 2, correct? Drawn from bag number 2. Probability of drawing from bag number 2 under the condition it is a red color, correct? It is a conditional probability, but how the conditional probability is coming? Probability of a ball drawn from bag number 2 given that ball is a red color, correct? So this is the idea here. Now see, bag number 1 there are black balls and there are red balls, and bag number 2 also there are black balls and there are red balls, correct? Now for example, bag number 1, the event of choosing bag number 1 I am taking as E1. So here this is E1, okay, and bag number 2, choosing the choosing event of choosing bag number 2 is E2, okay, and here ball drawn is a red color, correct? So A means event drawing a red ball, because one ball we are taken random, that ball found to be red color, correct? So A means event of drawing a red color. So that is why I am highlighted here red color. Okay. So which branch we need to take? We can see that one. See, red color I am highlighted that one because ball drawn red color. Okay, it was red color. Now when we are coming to this one, what is the question we need to calculate? Find the probability that drawn from bag number 2. Bag number 2 means choosing bag number 2 means E2. Under the condition that ball is a red color, correct? Drawing a red ball means what is the letter we are using? A. So what is the question we need to calculate? Probability of E2 given A. That means probability of drawn ball from bag number 2 under the condition it is a red color, correct? So this is what we need to do. So here you can see E2 coming on the top side, partition, correct? This is the partition coming on the top side. Partition coming on top side means it is the reverse probability. This is what we are using Bayes theorem. This case we are using Bayes theorem or Bayes rule. Hope you understood that question. Probability of a main event divided by an event, given an event already red color from bag number 2, like that. Okay, so this is Bayes theorem we are using. Now how to calculate, you can see. Okay, when we are going to this tree diagram, probability of E1 we are writing here, probability of E2 we are writing here, probability of, okay, what we are doing, red ball only we need to consider. So probability of red ball means A from bag number 1, E1 we write here, and probability of red ball, that means A given bag number 2, that is E2 we are writing here. Okay, this number we are taking because whatever ball we drawn is a red color, so no need to think about black color, that ball. This point you can see. Now what is probability of E1? Probability of choosing bag number 1, correct? Probability of choosing bag number 1. How many bags we have? 2 bags. So probability of choosing one bag number 1 means, what is the probability? Just half, 1 divided by 2, because totally 2 bag, 1 bag we are choosing, first bag, 1 divided by 2. Same way probability of E2 means probability of choosing the event bag number 2. What is the probability? 1 divided by 2, because we have only 2 bag, 1 bag selection means half probability. So that half plus half you will get to 1 total. Here half, here half, half plus half, it is 1. Okay, probability should be 1, that too. Now we will go to the condition. Okay, so probability of E2 given A, this is what our question. So you can write the rule, Bayes rule, probability of E2 given A equals, what we do, probability of E2 multiply probability of A given E2 divided by total probability, probability of E1 multiply probability of A given E1 plus probability of E2 multiply probability of A given E2, correct? We discussed it just before how to write the Bayes rule, right? E2. So whatever the event here should be here and here. Down same, it is total probability only. So this is the Bayes rule, correct? Now what are the terms we need to calculate? We need to calculate this one, probability of E1, correct? Probability of E1 equal, and we need to calculate what is probability of E2 equals, and we need to calculate what is probability of A given E1, and we need to calculate this term, probability of A given E2 equals, correct? Top side also same only, probability of E2 and probability of A given E2. So these 4 terms if you are getting, we can calculate the answer using the Bayes theorem, correct? So we will go to first one, probability of E1, already we got, probability of selecting bag number 1 is half, probability of E2 also half. So we can write probability of E1 half, probability of E2 also half, correct? Now probability of A given E1, that means what is the meaning probability of A given E1? What is the meaning? That means probability of A means drawing a red ball, correct? Red ball given that it is from bag number 1, E1. E1 means bag number 1. So what is the probability of a red from bag number 1? So that answer you can write here. So what is the number, that one? Bag number 1, how many red balls are there? 3 red balls. Divided by that bag totally how many balls are there? 7 balls. So this is the probability. 3 divided by 7 we can write. I hope you understood that one, correct? Probability of a red ball from bag number 1. So from bag number 1 how many red balls are there? Divided by totally how many balls are there? So that is the probability, conditional probability A given E1. Now probability of A given E2, that means probability of a red ball from bag number 2. How many red balls are there in bag number 2? 5. Divided by how many total balls? 11. Correct? Now we can apply that number here. See, probability of E2 multiply probability of A given E2. This rule we can use. So A given E1 3 by 7 and A given E2 5 divided by 11. Probability of drawing a red ball, bag number 1, red ball from bag number 2, correct? So how many red ball divided by total number of ball. So Bayes theorem, when we are using, you will get the answer 35 divided by 68. So this is the question by using Bayes theorem. So it is easy idea, okay, but the tree diagram or that sample space partition, if you correctly understood, you can do the question easily. Okay, now let me go to the exercise. Okay, so let me go to the exercise. You can see a person has undertaken, question number 1, a person has undertaken a construction job. Okay, a person has undertaken a construction job. He is doing one construction job. He saw more workers are there. Now what happened? The probability are 0.65 that there will be a strike. So construction site, sometime workers will not come. They are having some strike, correct? They are not coming to the construction site. So job will be delayed. So there is a strike in the construction field site. What is the probability? 0.65. Okay. So strike coming. What is the probability is coming? 0.65. Okay. Now what is the next line? Next sentence is telling 0.80 that the construction job will be completed on time if there is no strike. Okay, if there is no strike, okay, the 0.80 construction work will be completed on time. Okay, if there is no strike. Now 0.32 construction job will be completed on time if there is a strike. So if workers are not coming correctly, that means if there is a strike means 0.32, okay, work will be, that means 32% work will be finished on time. Okay, if there is a strike. Hope you understood. Now what is the question? Determine the probability that construction job will be completed on time. Okay, on time. So completed on time. This is our main aim. Main aim is that one, correct? Completed on time. So completed on time, determine the probability that the construction job will be completed on time. This is the question. So here when we are thinking, what is the partition of the sample space actually? We have one sample space here, correct? What is the partition actually? Partition means this construction job, sometime the strike will come, sometime no strike will be there, correct? So this is the partition, disjoint set, correct? So first partition, this is the first partition, correct? Strike and no strike. Now what is our event actually here? What is we need to do that one? Complete the work on time, correct? Complete the work on time. So this situation, if you are representing by a tree diagram, you can see. So the partition of the sample space I am marked here. Okay, this is the partition of the sample space. Strike or no strike, correct? Strike or no strike. So starting like, see, main events are strike or not strike, and if it is a strike, how much percentage we can complete on time? If it is a strike not on time completion, what is the probability? Okay, if there is a strike not on time completion, what is the probability? Online completion, what is the probability? Even if it is a strike, online completion, on time completion, what is the probability? If there is no strike, on time completion, what is the probability? If there is no strike, not on time completion, what is the probability? So this is the idea of that question. Hope you understood that one. Now what we do here, we are defining the events here. Okay, what are the events we are defining? Okay, we can see the event I will define here. First we are taking strike. Strike we are taking the event E. Okay, no strike means just complement, E complement. E complement. No means complement. Okay, not in E. Not in E. That is the meaning, E complement. Otherwise, if no means no there means we can take E1, E2, no problem. Why I am taking here E and E complement? Because strike, no strike. Strike we are taking E means no strike, not in E. That means E complement. So the first partition we are taking like E letter. I can just mark here the E letter, and no strike we can represent by the E complement letter. Okay, so I am just starting first the E letter, event. What is the meaning of that one? The event or the partition that there will be a strike, correct? There will be a strike. Now E complement, what is the meaning E complement? E complement means there will not be a strike. Hope you understood. There will not be a strike. That is the meaning E complement. Now here we written in short way E and E complement. Now what is our aim actually? What is our event here? Complete the work on time, correct? Construction job will be completed on time. So I can take that as A. That means on time completion. This is we are taking as A. So here also you can see on time completion. This is what we are concentrating, this event A. So I can take here A means on time completion, correct? Or we can write like construction job will be completed on time. Just you can write on time completion also. This is the event A. Now what is our question? You can see what is our question actually. Determine the probability. You can see the last line. If you understood the notations, now you can read the last line of the question. Determine the probability that the construction job will be completed on time. Completed on time means we are represented A letter, correct? Determine the probability. So what we need to do the question? Calculate probability of A equal to. This is what our question, correct? Determine the probability that construction job will be completed on time. That means what is the probability of A, correct? So here the question is actually nothing but we need to calculate probability of A equals. This is what our question, correct? That means if you want to calculate probability of A is coming here and here also A coming, correct? So it is just like a total probability. We need to do, how we need to do that one? We need to start from this line, multiply this, plus this line, multiply this one, correct? So that we will get a total probability, correct? This is what? Probability of E. What is this one? Probability of A given E. Now what is this one? Probability of E complement. What is this one? Probability of A given E complement, correct? Probability of A given E complement. So I am just writing the rule here now first. Total probability. So probability of A equal, what was the rule we studied? First probability of the partition, first partition E, multiply probability of A given E, plus probability of second partition, that is E complement. In the rule we are taken E1 and E2, but here E and E complement. So probability of E complement multiply probability of A given E complement, correct? This is what the rule for finding total probability, correct, of two events, okay, two partition, total probability equal to. Now check the number one by one. What is probability of E? What is probability of A given E? What is probability of E complement? What is the probability of A given E complement? These four number we can calculate, and if you are applying here you will get the answer. So let me start with the first probability of E, correct? You can see the question now. What is the meaning probability of E? E means strike, probability of strike. I wrote here. What is the probability of a strike? 0.65, correct? So probability of E means 0.65. I can write here probability of E equal to probability of a strike, correct? strike in the construction field is 0.65. Hope you understood, correct? Now, if you want to calculate this one, probability of E complement. Probability of E complement. What was the rule? Probability of E complement 1 minus probability of E, because total probability is 1. Subtract 1 minus probability of E. What we get? 1 minus 0.65. What is that number? 0.35. 0.35. So here we will get 0.35. Hope you understood that one. 0.35. Okay. Now, next one what we need to do? Probability of A given E. That is the next calculation. Probability of A given E. So I can do here. Probability of A given E. What is the meaning probability of A given E here? This number, correct? This number we need to calculate. Probability of A given E. That means probability of A means, what is the meaning? On time completion given that E is strike, correct? On time completion if there is a strike. That is the meaning probability of A given E. So see, if there is a strike on time completion, what is the value we written here? 0.32, correct? 0.32. So probability of A given E means 0.32. I can write here 0.32. That means probability of on time completion if there is a strike, correct? Here it is mentioned, see 0.32, that the construction job will be completed on time if there is a strike. This line, that one. Okay, hope you understood. Now the second one we need to calculate probability of A given E complement. What is the meaning of that one? Probability of on time completion if there is no strike. We need to write that number here. If there is no strike, okay, on time completion, what is the probability? See, I am written here, no strike. What is the completion, on time completion probability? 0.80, correct? That means here it is mentioned here 0.80 construction job will be completed on time if there is no strike, correct? 0.80. So I can write here 0.80. So all the number we got, probability of E we got, probability of E complement we got, probability of A given E we got, and probability of A given E complement we got. So just apply here, you will get the answer. Probability of E 0.65, probability of A given E 0.32 plus probability of E complement 0.35 multiply A given E complement 0.80. So what is the answer getting? Equals 0.488. This is the probability, that total probability that the construction job will be completed on time. Hope you understood that one, correct? So here not applying Bayes theorem, the total probability rule we are applying here. Okay. Now let me go to the second question. In a mill, okay, in a mill there is paper manufacture. Okay, so we are going to a paper manufacture mill. Okay, there is a probability that 0.80 for a power outage. Okay, so I am writing here power outage. Power outage means there is no power cut. Power outage probability 0.80. Okay, power outage probability is 0.80. If there is no power outage, okay, no power outage, if there is no power cut, okay, there is a probability of 0.60, okay, 0.60, and if there is a power outage, okay, if there is a power outage, the probability of 0.42, okay, that the order will be finished on time finishing. Okay, on time finishing. If no power outage, 0.60 on time finishing probability. If there is a power outage, 0.42 on time finishing probability. Now find the chances, find the probability of timely order delivery. Timely order delivery, this is our main event we are representing by A, correct? Timely order delivery. So what are the partition here, and what is the event we are considering? You can think about that one. What are the partition actually? Power outage, no power outage, correct? So I can see the tree diagram. So sample space we can divide into two partition, like one is power outage, second one no power outage. No means complement, okay? So no power outage and power outage. So power outage we can represent by E letter. No power outage means just to complement, because no power outage, not in E, that means E complement. Now what happened? What is our main event? Timely order delivery, correct? Timely order delivery. So this is what we need to consider. Timely order delivery, I can take it as A. Here also timely order delivery, I can take it as A, correct? So if power outage, timely delivery. No power outage, timely delivery, correct? No timely order delivery also there, but here the event we are considering is timely order delivery. Hope you understood the situation, correct? So we can go to the question now. So E means, what is the meaning? Occurrence of power outage. Occurrence of power outage. You can write power outage simply. And E complement means no power failure, correct? Or power outage. No power failure. Capital A. So E and E complement are the partition of the sample space. Now we are taking the event A. A means timely completion of delivery, correct? Or order. Timely completion of delivery, correct? Or order. Now what is the question you can think first? Is it Bayes theorem or total probability, like that? So what is the question here? Find the probability. Find the chances means find the probability of timely order delivery. That means what is the question? Probability of timely order delivery means A. What is P of A? That is the question. Probability of A, correct? That means the probability of A means what are the route we need to go from here? Power outage, timely order delivery. No power outage, timely order delivery, correct? Both here A coming. See, here also A is there, here also A is there. So both A we need to consider. So that means we need to calculate the total probability. Probability here and probability here. If power outage, the probability, and no power outage, the probability. Then add these two. That is the meaning, total probability. So here the question is total probability, correct? That means probability of A equals first probability of the partition E multiply probability of A given E plus probability of second partition E complement multiply probability of A given E complement, correct? This is what the total probability rule we are discussed. So just going to calculate what is probability E, what is probability of A given E, probability of E complement, and probability of A given E complement, these four numbers. So I can do here that one by one. First we are doing what is probability of E. That means probability of E means power outage, correct? Power outage, what is the probability? We are written here. Power outage, what is the probability number? 0.80, correct? Already given in the question, 0.80. Now we need to calculate probability of E complement. Probability of E complement, that means probability of no power outage. So probability of E complement means 1 minus probability of E, correct? What is that number? 1 minus 0.80. 1 minus 0.80 means, what is that number getting? 0.20. Hope you understood. So Here what is the probability of E? We got 0.80. Here what is the probability of E complement? We got 0.2, correct? 0.20. Now we need to calculate what is the probability of A given E. A given E means, what is the meaning? Probability of A means timely order delivery under the condition power outage. Power outage, timely order completion. What is the probability? That we need to write here. Probability of A given E. We need to write here. Probability of A given E complement. We can write this branch. So what is the order? This one, probability of A given E and probability of A given E complement. These two number. A given E means timely order delivery under power outage. Correct? So here I am written. See, under the power outage, on time delivery, what is the number? 0.42. Correct? So we can write 0.42. Now probability of A given E complement, that means timely order delivery under no power outage. Correct? What is that one? Here it is written. No power outage, on time delivery is 0.60. 0.60. Hope you understood. Now these four number you can apply here. You will get the answer. So 0.80 probability of E. A given E means 0.42 plus probability of E complement 0.20. A given E complement 0.60. So totally 0.4, 5 and 6. So this is the total probability. I hope you understood this question. Okay, now let me go to the third question. Suppose that there are 3 bolt producing machines. 3 bolt producing machine. How many? 3. That means sample space, how many partitions are there? 3 partitions. M1, M2 and M3. In different capacity like 30%, 20% and 50% respectively. That means machine number 1, okay, producing, bolt producing capacity, how much it is? Percentage? 30%, correct? And machine number 2 capacity is 20% and machine 3 capacity is 50%. Total production 30% from machine number 1, 20% from machine number 2, 50% from machine number 3, correct? Now the machine also produce defective bolt. This is what our main idea, defective bolt, correct? For example, 5%, 3% and 2% respectively. That means machine number 1, from machine number 1, 5% production are defective bolt. Machine number 2, 3% of production are defective bolt. And from machine 3, 2% production are defective bolt. These are defective, correct? Defective bolts in the production. So if the bolt is taken randomly, okay, one bolt you are taken randomly, what is the probability of getting defective bolt? What is the probability of getting a defective bolt? That is the question here. So you can see the tree diagram, okay, for understanding more. So from here there are machine 1, machine 2, machine 3, correct? How many partitions are there in the sample space? 3, M1, M2, M3. Now machine number 1, producing machine number 1, I am taking the event as E1, machine number 2 production E2, that event, and machine 3 production as E3, okay? Producing, bolt is produced by first machine E1, bolt producing by machine 2 E2, bolt producing by machine 3 E3, okay? So M1 means E1, E2 and E3. Now in the machine number 1, what is the percentage of production? 30%, correct? So here we need to write what is probability E1. Here we need to write what is probability of E2. Here we need to write what is the probability of E3, correct? 30% means how to change into probability number? 30 divided by 100, correct? That means 0.30. 20 divided by 100, that is probability of E2. 50 divided by 100, probability of E3. Now, actually machine number 1, maybe defective bolt will be there, good bolt will be there. Machine 2 also defective will be there, good bolt will be there. Machine 3 also defective will be there, good will be there. How much defective percentage? We are concentrating only defective bolt, correct? 5% defective, machine number 1. Machine 2 3%, machine 3 2% defective, correct? So here I am defining the event one by one. E1 means bolt is produced by first machine, correct? And E2, here I cannot write E complement like that because it is different event, correct? So E2, bolt is produced by the second machine, and E3, the bolt is produced by the third machine, correct? By the third machine. Okay. Now, what is the event A we are taking? Another main event. A means defective bolt, correct? Getting a defective bolt. Getting a defective bolt. Hope you understood that one. This event we are taken. So, this is the idea. Now, what is the question? What we need to calculate? Find the probability. What is the probability that getting a defective bolt, correct? Getting a defective bolt, what we are taken? A. So, what we need to calculate here? Probability of A. That is the question, correct? Probability of getting a defective bolt. Probability of A. How we are calculating probability of A? See, probability of A means defective. D. D means A, correct? Defective bolt, that is the event A. So, see here D is there, here D is there, here D is there, correct? So, how we need to calculate? First probability of E1 multiply probability of A given E1, then probability of E2, probability of A given E2, probability of E3, probability of A given E3, correct? These three we need to take, we need to consider. So, probability of A given E1 we will get here, probability of A given E2 we will get here, probability of A given E3 we will get here. Okay. So, we need to write the total probability here. So, I can write the total probability. What will be the rule? Probability of A equals first partition E1, probability of E1 multiply probability of A given E1, the first branch, plus second partition probability of E2 multiply probability of A given E2, correct? Plus the third partition, because here we have three partitions. So, probability of E3 multiply probability of A given E3. This is what we are telling, the total probability, correct? All the branches we need to consider here. So, what we do? We need to calculate this number. What is probability E1, A given E1, probability of E2, A given E2, probability E3, A given E3. This 6 number we need to calculate here. So, here we will do that one. First we need to calculate what is probability of E1, probability of E2, probability of E3, correct? Then we need to write what is probability of A given E1, probability of A given E2, and probability of A given E3, correct? These three. Okay, what is the probability of E1 first? Probability of E1, 30%, correct? 30%, probability of machine 1 production, 30% of production. That means 30 divided by 100. If you are changing percentage to number, divide by 100. you will get 0.30. Same like probability of E2, machine 2 production probability, the 20% it is, that means 20 divided by 100, 0.20. E3, 50%, correct? That means 50 divided by 100, that means 0.50. Okay. Now let's see A given E1. What is the meaning A given E1? Probability of defective bolt from machine 1, correct? Defective bolt from machine 1 we are written here. See how much percentage defective from machine 1? 5%. Machine 2 how much? 3%. Machine 3 2%. So here 3% it is given in the question. First one 5%. So 5%, 5% from machine 1 defective, and 3% from machine 2, 2% from machine 3. Convert that into probability. So 5 divided by 100, you will get 0.05. Here we will get 0.03. Here we will get 0.02 when we are dividing by 100, correct? Now all the value we got now, we can apply here. So equals probability of E1 0.30 multiply probability of A given E1 0.05 plus probability of E2 0.20 multiply A given E2 0.03 plus probability of E3 0.50 multiply A given E3, that means 0.02. When we are calculating, you will get the answer 0.031. Okay, hope you understood how to calculate the total probability. So first 3 questions we did related to the total probability, okay, in the exercise. Now we are going to do the questions from Bayes theorem, okay, going to do the question from Bayes theorem. So this total probability, once you understood Bayes theorem, questions will be easy, okay. Now suppose that there are 3 bolt producing machines M1, M2, M3, the same question whatever we did in question 3, but the question is different, okay, numbers all same, situation also same, question is different. Okay, M1, M2, M3 different capacity 3. So first machine, machine number 2, machine number 3, first machine 30% of the total capacity, 20% and here 50%, correct. Now the machine also produce defective bolt, correct. The machine also produce defective, not good bolt, correct. Defective bolt, machine 1 5%, same before question, machine 2 3%, machine 3 2%, situation is same before question respectively of their production. A bolt is taken randomly and find to be defective, correct. So defective bolt, that is the event A, defective bolt. What is the probability that bolt will be produced in machine 3? See, produced from machine 3. Before question what it was? Before it was probability of getting defective bolt. Defective bolt, what is the probability? That is probability of A. But here what is the question? What is the probability that bolt will be produced from machine 3? Machine 3 means our partition, correct? Machine 3 means our partition. So probability of a partition given that it is defective. So using the Bayes theorem. Hope you understood. So we will write the situation. You can see the tree diagram. There are 3 partition M1, M2 and M3. Okay, M1, M2 and M3. So we are defining the events here. E1 means bolt is produced from machine 1. Bolt is produced from machine 1. E2, bolt is produced from machine 2. E3 bolt is produced from machine 3, correct? And capital A be the event, what we are taken, bolt is defective, correct? Bolt is defective. Okay, so what is the question? First identify, find the probability that the bolt produced from machine 3, that means probability of machine 3 means E3, given that it is defective, that means A means defective bolt. This is what our question, probability of E3 given defective bolt, that means by using Bayes theorem, because you know partition is on the top side, correct? E3, so probability of a partition, that is machine 3, under given that it is defective, correct? So Bayes theorem we are using here. So using Bayes theorem, what we need to calculate, probability of machine 3, if it is from machine 3, given that bolt is defective means capital A we are using here, correctly mentioned, this is the partition, correct? That is why using the Bayes theorem. So equal to, what is the rule we are studied, probability of the particular partition, particular machine, probability of E3, because here probability of E3 given A we need to calculate. So probability of E3 multiply probability of A given E3 divided by total probability. Total probability means start from probability of E1, probability of A given E1 plus probability of E2 multiply probability of A given E2 plus probability of E3 multiply probability of A given E3, correct? Probability of a particular partition, that is on the top, divided by total probability, all the partition probability. Okay, so we will get like this. Now we need to calculate these values, each values. First we need to calculate what is probability of E1, same like last two questions, probability of E2, probability of E3. Okay, after that we need to calculate probability of A given E1, probability of A given E2, probability of A given E3, correct? So here this is probability of E1, this is probability of E2, this is probability of E3, correct? And here probability of A given E1, this is probability of A given E2. A means defective bolt, D means A, same. M1 means E1, M2 means E2, M3 means E3, correct? So probability of A given E3. Okay, so we can write the answer one by one. What is probability of E1? 30%. That means 30 divided by 100, 0.30. Probability of E2, 20%. That means 0.20. E3 probability 50%. That means 0.50. Correct? Now A given E1. What is probability of A given E1? That means probability of a defective bolt from E1, from machine 1. How much percentage it is? 5%. From E2, how much percentage defective? 3%. E3, 2%. So 5% means 0.05 divided by 100. 3% means 0.03. 2% means 0.02. Now we can apply these numbers here. You will get the answer. Probability of E3. If you are applying here, you will get 0.0140 divided by, or I can apply here if you want the numbers. So probability of E3, that means 0.40, multiply A given E3 means 0.02, divide probability of E1 number is different. Probability of E3, what is the number? 0.50, not 40. 0.50. Probability of A given E3 means 0.02, divided by probability of E1 means 0.30, multiply A given E1 means 0.05, plus probability of E2 0.20, A given E2 0.03, plus probability of E3 0.50, multiply A given E3 means 0.02. So the final answer you will get like the number 0.010 divided by 0.085. So the answer equal to 0.12 approximately we can write. Hope you understood this question. Now same model, one more question you can do, question number 5. You can see question number 5 now. What is question number 5? Suppose that there are 3 bolt producing machines, M1, M2 and M3. So we have M1, M2, M3. Different capacity like 25% first machine, 35% second machine, 40% third machine. Correct? Now the machine also produce defective bolt. Here also event is defective bolts. Is first machine 5% defective, second machine 4%, third machine 2%. Correct? Respectively of their production. A bolt is taken out randomly and found to be defective. Correct? What is the probability that the bolt produced from machine 2, see, produced from machine 2, machine 2 means partition, correct? So you can see the tree diagram like this, that same idea, like this it is coming, 3 partitions. So we can do E1, first event, bolt producing, bolt is produced from machine 1. E2, same bolt is produced from machine number 2. E3, correct, bolt is produced from machine number 3. And A, what is the event A? Bolt is defective, correct? Bolt is defective. Now what is our question, you can think? What is the probability that bolt is produced from machine 2? Probability that bolt produced from machine 2 means E2 under the condition given that that bolt is a defective bolt. Defective bolt we are representing by A letter. You can use D letter also, no problem. Probability of E2 given A. This is what the question. So this is by using Bayes theorem we need to calculate, correct? Bayes rule we need to apply here because partition is on the top side, correct? Partition, probability of reverse probability. So we will go to this question. We need to calculate by using Bayes rule probability of selecting machine 2, correct? Under the condition it is defective. Probability of E2 given A equals, what we write, probability of that particular partition, probability of E2 A given E2, correct, divide total probability, that means start from E1, probability A given E1 plus probability of E2 multiply probability of A given E2, then probability of third partition, probability of A given E3, correct, equals. Now we need to calculate these numbers separately. what is probability of E1, what is probability of E2, probability of E3, correct? Probability of E1 means probability of producing machine 1, 25%. That means 25 divided by 100, need to change into probability, so divide by 100, 0.25. Probability of E2 means 35%, that means 0.35. E3 means 40%, that means 0.40, correct? Now we need to calculate what is probability of A given E1 defective bolt from machine 1. How much percentage? 5%. Probability of defective bolt from machine 2, A given E2, 4%. Probability of defective bolt from machine 3, E3, that means 2%, correct? If you change into probability, percentage change to number 0.05, 0.04 and 0.02, correct? Now apply here in this rule, okay? All this number we are applying here, probability of these numbers. So probability of E2 means 0.35. A given E2 means 0.04. Divide probability of E1 means 0.25. A given E1 means 0.05 plus probability of E2 0.35. A given E2 0.04 plus E3 probability 0.40. A given E3 means 0.02. So you will get the answer equals, okay, answer equal to 0.0140 divided by 0.0345. So that means you will get 28 by 69, or you can write approximate number also, 28 divided by 69. Hope you understood this question. Now we will go to the question number 6. Okay, question number 6. A bag contains 4 red balls and 4 black balls. First bag number 1, 4 red balls, 4 black balls. And another bag number 2 contains 2 red balls and 6 black balls, correct? That means bag number 1 totally how many balls? 4 plus 4, 8 balls. Bag number 2, how many balls are there? That means 2 plus 6, that means 8 balls, correct? Now what we need to do, one of the 2 bags selected random, ball drawn from the bag which found to be red ball, okay, we got red ball. So A means what we need to take? Red ball, correct? Red ball. So find the probability that ball drawn from first bag means partition, correct? Partition. So as we did the example, same model, this question. So this tree diagram you can see clear. There are 2 partitions in the sample space. Sample space we can divide into 2, like bag number 1 and bag number 2. These are the partitions, correct? So bag number 1, how many balls? 4 red, 4 black, totally 8 balls. Bag number 2, how many balls are there? 2 red, 6 black, 8 balls will be there, correct? Both bag 8 balls are there. Now bag number 1, we have black and red balls. Bag number 2 also we have black balls and we have red balls, correct? Yeah, this is the tree diagram representing that question. Now partition, as I told you, bag number 1 and bag number 2, correct? So we can write the events first, okay? E1, what is the event E1? Actually event of choosing bag number 1, correct? Choosing bag number 1. E2, choosing bag number 2, correct? Then event A means what ball we got when we are getting a red ball, correct? So drawing a red ball. This is the event A, correct? Now what is the question? You can see what is the question we need to do. Find the probability. We need to calculate the probability that the ball drawn from the first bag, correct? That means the probability of ball drawing from the first bag. First bag means E1 under the condition given that that ball is a red ball. Red ball means A. So probability of E1 given A. Okay, so we need to use the Bayes rule, correct? Bayes theorem. E1 given A, partition on the top given A. So Bayes rule, reverse probability it is, correct? So we will write the rule. Probability of, question is by using Bayes rule, Bayes theorem, probability of E1 given A. First bag is a red color, correct bag. So how to write the rule? Probability of that particular bag E1 here. Probability of A given E1 divided by total probability. Here only two partition. So starting from first partition, probability of A given E1 plus probability of E2 multiply probability of A given E2, correct? Two partition only, so two terms on the down, total probability. Now we can check what is the probability of E1, what is the probability of E2, what is the probability of A given E1, probability of A given E2 equals, correct? These four numbers we need to calculate. First, what is the probability of E1? E1 means probability of selecting bag number 1. How many bags we have? 2 bags. Selecting one bag, what is the probability? 1 divided by 2. One bag from 2. So 1 divided by 2. Probability of E2, probability of selecting bag number 2 also, only one bag number 2 divided by total bags 2, correct? So probability of E1 half, probability of E2 also half. Now probability of A given E1, probability of A given E1, that means probability of a red ball from bag number 1, correct? So how many red balls are there in bag number 1? 4 red ball. Divided by total, how many balls are there in that bag? 8 ball. So that is the probability of A given E1. That means probability of a red ball from bag number 1. Red balls are 4, total balls are 8. Now same way probability of A given E2, probability of a red ball from bag number 2, correct? So bag number 2, how many red balls are there? 2. Divided by how many total balls are there? 8. So 2 by 8, correct? So all four number we got, can apply here, we will get the answer. So probability of E1, 1 over 2. Probability of A given E1, 4 by 8. Yeah, 1 over 2, 4 divided by 8. Divided by, now probability of E1, that is 1 over 2. Multiply probability of A given E1, 4 divided by 8. Plus probability of E2, that is 1 over 2, multiply probability of A given E2, 2 over 8, correct? So when we are calculating, you will get answer equal to 2 over 3. So this is the probability E1 given A by using Bayes theorem. Hope you understood this question. Okay. Now let me go to the last question. A coin is tossed with a weight, probability of head equal to 3 by 4, probability of tail equal to 1 over 4. When a head appears, a number is chosen random from 1 to 9. When a tail appears, a number is chosen random from 1 to 7. Find the probability of getting selected an even number. Calculate the probability of odd number selected. This is the question here. So a coin is tossed. So when we are taking sample space, we can take the partition as, okay, one is head and the second one is tail, correct? Getting tail and getting head, that is the two partition. Head we are representing E1 or this is E2, correct? E1 and E2. Now what happened in the question, you can see probability of head already given. E1 means probability of head, E1, or I can take a head also, T also tile, instead of E1 E2 head and tile, correct? So probability of head, that means probability of E1, what is given, equal to 3 divided by 4. Second one, probability of tile, okay, like the probability of E2, the weight is given, that is 1 over 4, correct? Now you can continue reading. When a head appears, okay, if you go to head, what we do, a number is chosen from 1 to 9, okay, a number will choose from 1 to 9, okay, see like this, 1 2 3 4 5 6 7 8 9, a number is choosing from 1 to 9 if head appears. When a tile appears, what happened, when a tile appears, a number is chosen random from 1 to 7, okay, we can choose a number random from 1 to 7, 1 2 3 4 5 6 7, a number we are choosing random from 1 to 7. If head getting 1 to 9, one number you are choosing. If tile getting means 1 to 7, one number we are choosing, correct? Now find the probability. First question, find the probability of getting selected an even number. This is the first question. Two questions are there, separate question. Find the probability, we need to calculate the probability of getting selected an even number, okay? So what we do for here, a means getting an even number, correct? Selected number is even, selected number is even, that is a, the event a. So what is the question we need to do? Probability of selected number is an even number, that means probability of a we need to calculate, correct? Probability of a we need to calculate. Selected number is an even number. Hope you understood that one. Even number means what are the even number? For example, here 2 4 6 8 are even number, correct? Selected number is an even number. Now same way second one also we can take. So we are calculating this one first, probability of getting selected an even number, probability of a equal to, correct? We have two partition, one is the head and the second one is the tile. E1 E2 we can represent, or H and T we can represent, correct? So what are the possibility we can write? Here also even number is there, 2 4 6, correct? So we need to write the rule first. We need to write the rule first. Probability of a equal total probability, okay? This is the question related to total probability, not Bayes theorem. P of a equal to, how we are writing? First partition, probability of E1 or probability of H multiply probability of a given H, correct? Probability of getting an even number, okay, when head given that head is occurred, correct? Plus probability that probability of t, second partition, multiply given that probability of a given t, correct? Probability of a given t, okay? This is what the rule here. Now we need to calculate these numbers separately, okay? What numbers we need to calculate? What is the probability of a given head and probability of a given tile, correct? So these two number if you are getting, we can apply here. So probability of a equal, see already this number, probability of h we know already. What is probability of h? 3 by 4. Probability of t we already knows, 1 over 4, correct? So only we need to calculate this number, probability of a given h and probability of a given t. What is the meaning probability of a given h? Probability of selected an even number. A means selected even number given that it is head, correct? Head occur selecting even number. You can see here, when head occur we are selecting from a number from 1 to 9. Out of these number, how many even numbers are there? 1, 2, 3, 4. 2, 4, 6, 8. Correct? 2, 4, 6, 8. That means 4 numbers will be there. So 4 even number divided by total number 9 number. So what is the probability here? 4 divided by 9, because we have 4 even number divided by totally 9 number. If head occurs means we are selecting number from 1 to 9. That is why total number 9, out of that 4 even number. So 4 divided by 9. Now same way, probability of A given T, probability of getting an even number when tile occurs. Tile occurs means what are the number we are choosing from where to where? 1 to 7. Out of 1 to 7, how many even numbers are there? 3, 2, 4 and 6. Correct? How many total number? 7 number. So what will be the probability of A given T? Probability of getting an even number when tile occurs. So how can we write that one? 3 divided by 3 even numbers divided by totally 7 numbers. 3 divided by 7. Correct? Now you can apply, you can calculate what is the probability of A equals, apply here probability of H, that is 3 by 4, 3 divided by 4 multiply probability of A given H, just now we got 4 divided by 9 plus, okay, plus probability of tile, that is 1 over 4 multiply probability of A given T, what is that? 3 divided by 7. So you will get the answer 37 divided by 84. Okay, this is the first part of the question. Hope you understood the first part. This is the A part of the question. What is the probability of selecting an even number? Okay, now we are going to the second part now. Calculate the probability of an odd number is selected. First part was even number, correct? Here odd number is selected. So in the second part, when we are doing, I am defining an event B. B means what we can write? Selected number is odd, correct? Selected number is odd, because that is different question. So another event we are taking, that is B. Selected number is odd. So what is the question we need to do? Probability of odd number selected. That means probability of B equal to how much? Total probability, again here we are calculating, correct? So probability of B equals, probability of B equal by using the total probability rule. What is total probability? Probability of B, you can read probability of first partition is H multiply probability of B given H plus probability of second partition tile multiply probability of B given tile, correct? Now check these 4 numbers one by one. We need to check what is probability of H, already we know. Probability of tile also we know. Just we need to calculate what is probability of B given H, probability of B given T. I can do on this side. First probability of B given H, what will be the number? Then probability of B given T. Okay. So what is the meaning probability of B given H? B means odd number selection. Given that head occurred. Head occurred odd number selection means what are the number? You can see. Okay. If head occurs, we are selecting a number from which option? 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct? If tile occurs, we are selecting a number from, what are the option? From 1 to 7. 1, 2, 3, 4, 5, 6, 7. Now, here first number we need to calculate probability of B given H. Correct? That means probability of B means the odd number given head, correct? Given that head occurred. How many odd numbers are there when head occurs? 1 is odd number, 3, 5, 7 and 9, correct? So how many number? 1, 2, 3, 4, 5. Totally how many numbers are there? 9 numbers. So 5 by 9, correct? Now same way, what is the probability of B under tile occurs, tile is given, correct? Tile is occurred. So B means odd number, that means probability of odd number when tile occurs, tile, correct? So how many odd numbers is there when tile occurs? 1, 3, 5, 7, that means 4 numbers, divided by how many total number? 7 numbers, 4 divided by 7. So we got these two number. B given H means 5 by 9, A given H means 4 by 7. Just apply all the number here. Probability of H means we already know, that is 3 by 4, multiply B given H 5 by 9, plus probability of tile means 1 over 4, multiply B given T means 4 divided by 7. So totally you will get answer 47 divided by 84. Okay. So this is the idea. So I hope you understood the questions from this section 5.3. So this section we are discussing the main theorem, that is we are calling Bayes theorem. Okay, hope you understood the ideas whatever we discussed. So thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.